I make this video for my class 0603, and here's the first question in my homework one. In this question, I need to show definitions and simple properties of several processes. The first is person process, and in this process we know that the definition is so later if we want to get the expectation of this process, we need to write this down, and it means that the sum of every stages equals 1. So we just open this here. So later change this part to the right. So this is the equation. Then later we need to do this. So we could get this one, and then we need to make this 2k. That's the reason why here is lambda t. Then later to this part, we change this part back to here. So obviously this is the expectation of xt. So the expectation of this process is lambda t. And later we need to get the correlationship. The autocorrelationship is this. We could write it down in this way. So obviously it should divide it into two parts. This is the first situation and this is the second situation. In the first situation, we could just separate these two because they are non-overlapping. So from the thing we just get from here, so we could easily write down these two. Later, this is the result. If it is in the second situation, it means that they are overlapping. So the first thing we need to do is that separate them, make them not overlapping. Then this is the thing we could do. Just separate them into 4 parts, and these 4 parts are not overlapping. So we could write it here. But there's one thing we should be careful is this part. Because this part and this part are the same, so we could not just make them like expectation times expectation. We should write it in this way. Then later we could get the result, and here's the result. If T1 is not less than T2, so here's the result. We just change TC, TB, TA, TD to the thing we want. So obviously we could get this one. If T1 is not bigger than T2, so here is the result. Well, the second process is Poisson increment process. We have already know that the Poisson process is xt. So here is the definition of Poisson increment. Well, obviously from here we could easily get the expectation. We just write this down, and later the yt could change into way to write it. So it is this one. So obviously we could know that this is lambda because this equals this one, and this one I could rewrite it like this. So obviously here is a result. And the second thing we want to get is the autocorrelationship correlation. So here the autocorrelation could be written into this way, obviously, and later we just make them like this. So what we need to do is to discuss it in different situations. Since we could write the points we need to discuss here. The first is that if T2 is bigger than 1, T1 plus sigma, so obviously we could get this since they are non-overlapping. And later, if T1 is bigger than T2 plus sigma, so we could write the expectation into this way as well, since it's non-overlapping. Later, if T2 is less than T1 plus sigma but bigger than T1, it means that they are overlapping. So we just use the method we used in the first process, Python process. We need to separate them into several parts. This is the first part, second part, third part, and fourth part. So we just write it down because here we make them non-overlapping. So we could just calculate them easily. In the first situation, the T1 is less than T2 plus sigma but bigger than T2. So here we need to separate them in 4 parts since they are overlapping. We need to make them to non-overlapping. So here is the result. Well, so from the whole situations, I just showed the 4 situations, so we could get the summary here. So here's the result. Well, later I can discuss about the third process, this Python hypothesis. Here's the definition, and xt is Python process. So obviously, in this one, the expectation of Python impulse, I could write this down like that. Obviously, this part is lambda t, so here is lambda, and the autocorrelation here should be right like this. Just to put this part out. And later, well, this one is the result we have already get from the first question in the Python process. Since this is the autocorrelation of Python process, so we could write this in this way. Later, just make some calculation, so we could get the result here. This is the result. Well, in the fourth process, semi-random telegraph signal, and here's the definition. So obviously here, if the probability that xt equals 1, well, xt here is Python process as well, so we could just write them in this way, and here this could be write into the form like this. And later this one, use a similar way, we could know that it could be right into this one. So obviously the expectation of xt here should be right into these 2 parts. Since this is when xt equals 1, so it should be the probability times the variable 1, and here it should be the probability times -1. So here is the result. Later the correlation should be right into this way, obviously. Use a similar way to solve the problem. We could just write it into this one and this. So if T1 is bigger than T2, we could get this result. Well, if T2 is bigger than T1, so we could get this result. Here is a summary of the result. Well, if this is a random telegraph signal, and here is the definition. So here we could get the expectation. Here is the expectation since A here. This is the express of A. So the expectation of A equals 0, so it is 0. And here the autocorrelation could be written into this way. Well, obviously here, this one is the autocorrelation of xt, the pattern process. But here, we could just calculate it out. So, well, actually, here's now the pattern process, since it should be the result of the last one, semi-random telegraph signal. So what we need to do is to put the semi-random telegraph signal, the result in. So here is the result of random one. Well, the sixth process is random walk. Random walk, here's the definition of random walk. So we could know that here is the expression. Well, the expectation here we could calculate this out. The expectation of x and t here. Here we could rewrite the x and t into the sum of xy, and here is the definition of xy. So if we write it into this way, obviously the expectation of yi equals 0, so the expectation of x and t is 0. And the autocorrelation here could be written into this way. Use the similar way. I just need to open everything out. But we could find that y1 and y2 are independent. So actually we just need to calculate the y1 times y1, y2 times y2. So actually the minimum of I and matters. So later just times s square. So here's the result. And the seventh process is Wiener process. Here is the definition of Wiener process. If we want to get the expectation of Wiener process, here is we just need to take the expression of Wiener process in. So here is xt. So xt here we could use the similar way we just used in the last process. We just need to change it into y. So here's yi. Obviously this is 0, so here should be 0. And the autocorrelation should be like this. Just put everything out, and here is the autocorrelation of the last process, random walk. So here is the result, and this is the result of the first question.